Hi, this is Dave Nicosia, Warning Coordination Meteorologist with NOAA's National Weather Service in Binghamton, New York. And I'm here today to talk to you about the winter outlook for winter 2015 and 16 for the National Weather Service Binghamton service area. Our service area encompasses 17 counties in central New York and 7 counties in northeast Pennsylvania, and we proudly serve this beautiful part of our country. We are one of 122 weather forecast offices, and our job is to become local experts. As we know, the weather varies dramatically from northeast Pennsylvania all the way up through central New York. There are a lot of different climate zones, and our forecasters tune in on these differences and provide the best possible forecasts for our area. Our main mission here at the National Weather Service: warnings and forecasts for the protection of life and property and also the enhancement of the national economy. But life and property and safety is the most important thing here at the Weather Service, and our job is to keep everybody safe. So, what's normal for winter in central New York and northeast Pennsylvania? As you'll see, some of these pictures I have on the screen here, you know, typically we don't see snow like that, though we hear stories about snow like that occasionally. And typically we really don't see a lot of below zero air. There are some exceptions, some winters, like last winter, and some winters we do indeed see a lot of snow. But what's really normal? That's what we'll talk about next. First of all, one of the big things when we talk about normal is the year-to-year variability in our temperatures in both New York and Pennsylvania. The average temperature, winter temperature, December through February in New York State is just under 22 degrees, and the average winter temperature in Pennsylvania is just under 27 degrees. So you can see temperatures generally average in the 20s and approaching 30 in our service area. But you'll notice these graphs go all the way back to the late 1800s, and they are the average winter temperature for each state. And you'll notice a tremendous amount of year-to-year variability. Some years are mild, and other years are cold, and you can see in both states. The last 2 winters were very cold, as you can see in Pennsylvania and in New York State. Winter temperatures were below normal, especially in February, which was a historically cold month. So the key point here is there is a lot of year-to-year variability in our winter temperatures, which makes forecasting winter temperatures around here a big challenge. What's the average annual snowfall? What's normal for snowfall? And on this map, you can see the lake effect areas of upstate New York in the Tug Hill Plateau region, where they get up over 200 inches a year in the purple and light purple here. You could also see the influences of Lake Ontario. The winds typically come from the northwest. You can see the influences of Lake Erie. And you could also see the influence of the coastal storm track in the Poconos. So most of our area averages, at least in the southern tier of New York and the Catskills and portions of Northeast PA, average between 50 and 75 inches of snow a year. As you get further north into the lake effect snow belts, most places average between 75 and 125 inches, so around 100 inches. And then you get up to the Tug Hill Plateau, and then snow amounts approach 200 inches per year. And then there also is an area in our service area from Elmira Corning to Towanda down to Wilkes-Barre Scranton that averages between 25 and 50 inches a year. So you can see there is a large amount of variation. What is the frequency of snowstorms or snow events in our forecast area? This shows the average number of days where you get more than 2 inches of snow, more than 6 inches of snow, and more than 10 inches of snow in a 24-hour period. And you'll notice Syracuse, 18 days for more than 2 inches, 3 days for more than 6 inches, and only 1 day a year more than 10 inches. And you'll notice as you get further south, away from the lakes, the incidences of really big snowstorms isn't as much as we perceive. We typically get 1 or 2 days where we get more than 6 inches of snow in Binghamton and Scranton, But a really big storm where we get double-digit snowfall once every 2 years in the Binghamton area and once every 3 years in the Scranton area. And how often does it go below zero in our area? You can see most places average generally, from the Scranton area, only 3 days to Wanda 6 days, Elmira 7 days, to as much as almost 20 days up in Boonville, up near the Tughill Plateau. So you can see it varies generally between 1 and 2 weeks, between 7 and 14 days where it actually does go below zero. But most of the time, we really don't see sub-zero temperatures, just but a few days out of the year. All right, so what are some of the main factors that we're looking at for this winter? And some of you may have heard about the strong El Nino event in the Pacific Ocean. That's going to be a major player in this winter. And another factor also that we can't forget about is the ocean waters in the North Atlantic that are colder than normal, and then we have warmer than normal ocean waters in the North Pacific. And why do we look at ocean waters? Well, the oceans hold heat a lot more so than air, and ocean temperatures tend to persist through the seasons. So if we look at what the ocean temperatures are here in the fall, we generally they will persist through the winter, and the ocean temperatures do impact the air temperatures and impact the jet stream patterns over North America and all the world for that matter. And if we can get an idea what the jet stream might look like, we can get an idea then of how stormy it's going to be and what kind of temperatures we may be looking at this winter. So let's talk about El Nino versus its opposite, La Nina. El Nino is a warming of the ocean waters in the equatorial regions of the Pacific Ocean. And you can see on the schematic on the left, the red indicates above normal ocean water temperatures. Conversely, a La Nina is colder than normal ocean water temperatures. And this is related to the trade winds across the Pacific. Trade winds blow from east to west, so from South America here towards Indonesia. Now, during El Nino, the trade winds fail and the waters warm up because you do not get upwelling. What happens when you have strong east winds across the Pacific? You get upwelling along the South America coast. So you bring this cold, deep water up, and the trade winds blow this cool water across the Pacific. So when the trade winds fail, the waters warm up, and that's what we've seen this year. During a La Nina, the trade winds get exceptionally strong, and you get colder than normal waters. Now, why does this matter? This matters because when you have warm ocean waters that are in the central and eastern Pacific, it shifts the thunderstorm activity that is very common in Indonesia and the western Pacific towards the central and eastern Pacific. And that adds energy to the atmosphere, and that strengthens the jet stream that comes in to the North America continent, especially the west coast. And a very strong Pacific jet stream means more storms off the Pacific. And that has impact for our winters. But one of the things I do want to talk about is this El Nino and La Nina are natural phenomena. This isn't anything unusual. The Pacific is constantly going back and forth. This goes back to the 1950s. We measure El Nino versus La Nina. There's an index. But basically, we go from La Ninas to El Ninos and back and forth, back and forth. It is a natural oscillation. In fact, it's called the Southern Oscillation, and this is the Southern Oscillation Index. So this year, we are going into a very strong El Nino pattern. In fact, this is the strongest El Nino pattern that we have seen since 1997-98. And this area indicates higher than normal sea surface heights, which basically means that water is sloshing back across the Pacific. The upwelling has ceased and the waters get warm. So this was 1997. This was 2000. This is 2015. So it's not quite as strong as 97, but it is definitely strong. And if we compare it to other El Ninos, the black line is 2015. And you'll notice that we are Not as strong as 97, but we're very close to 1982. So we are among the stronger El Ninos that we have seen in the last 50 to 60 years. So this is going to be a strong El Nino. So what does that mean? And like I said, it means that we're going to have a much stronger Pacific jet stream, which means Pacific storms. And we've already been seeing some snow and Pacific storms hitting the western United States. And what this means is that we're going to see more Pacific air into the lower 48. There's the polar jet stream that gets strong this time of year that delivers, polar and Arctic air masses for that matter into the Northeast. And we saw a lot of that last winter and the winter before. But this winter, we're going to see more Pacific air. In fact, this November, as many of you have noticed, has been pretty mild. And we've been inundated with Pacific air masses versus true polar and certainly not Arctic air masses yet. But things, as the fall progresses towards winter, things are going to change some. But the main point here is we're going to be seeing more Pacific air in the lower 48 and more storminess. So we tend to see stormy and milder conditions. However, that's not the whole story here. So let's go back to the and I'll get to this, but let's go back to the 1997-98 winter. That was the last time we saw a very strong El Nino pattern. We had two major snowstorms in central New York and northeast Pennsylvania where we got up to 2 feet in some spots. It was a very mild winter despite the snow. We had a monster ice storm, a devastating ice storm in the far northern part of New York State and Canada. But this El Nino is different, and that's what I want to talk about next. So let's take a look. So this is the sea surface temperature anomalies or departures from what is normal across the entire globe as of this October. And you'll notice the reds and oranges is above normal temperatures and the blues and purples are below normal temperatures. So you can see the El Nino pattern clearly in the equatorial regions of the Pacific. But look at the North Atlantic, colder than normal. Look at the North Pacific, warmer than normal. This pattern actually favors colder air in a stronger polar vortex, which suggests that there'll be colder air in Canada, which is different than the 1997-98 El Nino. You'll notice that it was warm in the North Atlantic and cold in the North Pacific. And again, you can see the characteristic El Nino sea surface temperatures. So this is different. So what this tells us is that the polar jet stream is going to be stronger this year too. So that forecast a little bit. El Nino, as I said, tends to bring milder than normal winters, but more winter storms. Since the ocean temperatures are different in the North Atlantic and North Pacific, that favors colder than normal like the last 2 winters. So we have some conflicting signals going on here. But one thing I think is for certain is we are going to see more winter storms this year in the Northeast United States. So this is the official NOAA outlook, and it is going for milder than normal conditions in the Northeast. And it does have higher than normal precipitation up and down the East Coast, suggesting more storms. So this storminess, I think, is a theme for this winter season. Winter storms and maybe some big. So if we downscale this national forecast to our area, we're looking at temperatures near to slightly above normal. So it'll be close to normal. Even if it was slightly above normal, it's still cold. It would still be cold enough for snow, more coastal storms. But since it's going to be a little bit warmer than normal, I think we're going to see less lake effect snow in our area. So I think we're looking at above normal snowfall from the southern tier of New York, Catskills to northeast Pennsylvania, mainly from the coastal storms, but below normal snowfall, Finger Lakes, Syracuse, Utica, Rome to the Duncan Plateau where they get more lake effect snow. I do think we have the potential for a really big snowstorm like we've seen in previous strong El Ninos, and we can't rule out the chance of an ice storm. Hopefully that won't be the case, but I think our odds are higher. And I do think we'll see more wild temperature swings where it gets really mild and then boom, the bottom drops off on the thermometer and it gets bitterly cold. So I think we're going to see a lot of that too as well. But I think in the end, it'll average near to slightly above normal. So it's going to be a very interesting and we believe active. Here's the breakdown. This is the snowfall relative to normal, 10 to 20% above normal from Northeast PA, Poconos up to the Catskills. Slightly above normal snowfall in between here, and then in the areas that typically get more lake effect snow, 10% below normal, and the Tug Hill 20% below normal. However, that's still quite a bit of snow, but I still think it is going to be an active winter, and we're going to see a lot of winter. Here's the temperature departures. I think areas in the north will see as much as 2 degrees above normal, but again, we're talking, it's still going to be a cold winter. It's just a little bit above normal, and then maybe 1 degree above normal or less in Northeast Pennsylvania. So slightly above normal, but compared to last winter, it is definitely going to seem mild because last winter was so cold. But this winter, we don't expect that kind of cold. So, how do you find information this winter? Well, we hope you visit our website at weather.gov/BGM. And we have social media presence. We're on Facebook, we're Twitter, and we're also on YouTube, and that's where you're viewing this YouTube channel. We hope you subscribe, and we are going to continue updates through the winter season on winter storms and other things that are going on interesting with the weather in our area. Thank you very much. If you have any questions, feel free to email me or give me a call.